So hello everyone. Today I would like to create a video about what I know about reverse engineering till now. Okay. So first let you tell the story. I have a phone, right? I have a phone. This is a phone which I am using. Let it increase it first, a little bit more thickness. I have a phone. Okay, which is too old. Okay, too old. And what I want is to design a complete OS, including kernel. Okay, so the phone I have is of MediaTek, uses MediaTek CPU. MediaTek CPU, ARM Cortex, which has ARM Cortex, means the CPU is of type ARM, Cortex A7, probably. Not sure about it. Okay, I am not sure. So I have to design a complete OS including kernel. This is my goal, and I have this much information about it. And the more I know is I have the complete packaged OS. I mean, I have complete packaged OS code, not code, like compiled, packaged, compiled code or files. Okay, and I also have the scatter file of my phone. I have scatter file. What this file does, it's like a distribution file, that how the different parts of the phone will be written. Mm, of the phone will be written. Okay, there are some more features of my phone. Okay, so can I write this one? Okay, let's create the phone once more. Okay, this is my phone. There are some more ports like 4 GB of ROM and 500 MB of RAM. These things I know, and more things I know, like there is cameras, GPS, Bluetooth, and sensors. It support no USB, but can charge with USB, micro USB, but can charge or data transfer with micro USB. Okay, so that are the things I know, and we have distribution of file, that how okay, that's the scatter file. So how my phone is designed, I would like to share. So there is a CPU part. Okay, there is one CPU part I know, which is ARM Cortex something, ARM Cortex A7, and there is a ROM part and RAM part. Okay, I'm dealing with mostly of these three things. And let me scroll first. Okay, these three things. The scatter file contains all the instructions, like all the partitions. Scatter file contains all the partition structure. all the partition structure. Okay, so whenever my phone boots, what I know till now after testing, whenever my phone boots, it's go to like CPU kind of thing. Then it checks for like if something is available like some kind of code to detect the CPU directly the CPU kind of thing like how can I say that? Okay, it detects if it's like ARM mode or something, ARM CPU, ARM code means it allows direct communication with the ROM, flashing of the ROM. Okay, it checks if flashing is available, flashing of ROM. Okay, so there is ARM Cortex A7, that's my CPU version, and flashing of the RAM. After checking, everything moves to like ROM and RAM. So how my CPU knows there's some kind of binary written on the ROM. This is a ROM, and this ROM is then divided into like many parts. Okay, many parts like preloader, and I can read and write this preloader and some secure partitions, U-boot and Linux kernel and user space, and there are something like recovery space. We will talk about the whole scatter file in a moment. So this is how the ROM is divided, and maybe the CPU is detecting the spatial sequence here and just loading that back. Maybe that's my thoughts. Okay, so I have this kind of thing. Okay, the U-boot is our little kernel bootloader, and there is a preloader. Okay, first partition of the ROM of the ROM. Okay, so this is the overall structure. Then let's talk about the scatter file first. Then we will come back to this scatter file. So for this, I will just open and copy some things. Let's check if that is available. Next, okay, I'm opening this. Okay, please wait a moment. So can I paste it here? Okay. So I'm able to paste this here. So this is my scatter file, right? And we will go one by one. So these are some of my information, information about my platform, about the CPU, about the device, about the structure or device info. Okay, this is device info. So this is my CPU version, probably CPU, and this is the board, and we have the storage type, eMMC, some kind of like SD card kind of thing. Okay, So it's not 4 GB block size is I think okay, not block size, it's 120 KB, right? If you convert it to like 0x 20000 this is about 128 kilobyte. And we have channel, boot channel, I don't know what this means, we will figure out later. And this is the partition information. Okay, so you can see that there is a first partition is our preloader first. Okay, and it loads the file name of preloader for a, this is the binary S4042AP. And there is the main boot record, this is the record entry for all the partition, record entry of all the partitions, of all the partitions. Okay, then next we have EBR. I don't know what EBR is, and this is some kind of like device info, maybe device info, not sure. And then we have NVRAM. I don't know what this does. I don't know. And then we have another thing which is protective, maybe protected information, maybe protected information. And it's also the same kind of thing. And we have set configuration, means maybe security or sector configuration. I'm not sure about it, not sure. And then we have U-boot. This is our little kernel. I know a little about it, because it's little, not little, it's fairly around, it's the size I got is 200 and something 34 around approx KB. The file size is this. And in a this is our Linux kernel, and after we have, now why it's opening, I don't know. Okay, then we have our recovery partition, maybe for recovery. And we have sec.ro, I don't know what this does. Miscellaneous, I also don't know what this does. And then we have a logo, this contains logos, boot images, and other things, other images are primary. And then when xpdb, I don't know what this does. And this may be the Android kind of thing, Android code. And area, cache area, and we will have user data, a name suggests user data. And we have fat, maybe to user storage partition, extra space storage, extra, maybe so something kind of pool, I don't know what this is for. So that's all. So these are the things which are available in the scatter file. Okay, now I will have to get something else to give you some more information that how much I have progressed. So these are all the things. Now I have a precompiled code. I have all the precompiled code, precompiled code, and I am using a software called SP Flash tool. MediaTek tool, it's kind of like MediaTek tool for flashing. Tool for flashing. So what it does, it takes the scatter file, or let me tell you something, or SP Flash tool. It takes the scatter file, okay, and there are more options. Like I can just format the whole flash, and the second one is I can upgrade the firmware upgrade, and the third option I have is to download things, download the scatter files, ones are distributed files. Okay, so I'm going to use is format and the scatter. There is also a section for ram test. Okay, so what I do is I am what am I doing now? So as I have the pre-compiled codes, I'm taking the starting from, like, not here because these are some sequential partitions and these are necessary, so I'm skipping all this and I'm directly going to this section, LK section. This section is little kernel. So here you can see lk.bin. This is a binary file. Okay, little kernel binary. So what I did till now is I have tried downloading the lk source code, lk from GitHub, and built that, compiled that, and tried to replace lk with the previous, this lk with this, replace previous lk with the new one, and tried to reboot it, and I failed. Okay, so this thing doesn't work like that because this MediaTek need special libraries, maybe need special libraries or compiler to compile things, compiler or code to compile this. So how would I do this? So how will I tackle this problem? So the only way is reverse engineering. And how the reverse engineering I'm doing is using Ghidra. Okay, bin work, and I'm using a Python language a little bit. So these are all the things, and how I'm doing the reverse engineering then now. So what I'm doing is, first I will try to edit something in LK, find the function, oh sorry, decompile it, then find a function, replace its binaries, bits, replace its bits, run, and we are happy. But that's not easy. So there are many problems I am facing. First, after decompiling after we analyzed in Ghidra, decompile it, I'm getting a function of what? Git draw function in assembly language. Hard. Okay, which is really hard. Another observation I did, another observation is that when I am flashing, okay, this is my phone. When I am flashing with up to U-boot, the screen is on and nothing shows on it. Shows on it. Okay, and if I had logo dot bin, not any other files, not any other partition, uh, like you uh, Android or kernel, Linux kernel. I'm not adding this or any other thing, just I'm adding logo and up to U-boot. Logo up to U-boot, up to U-boot plus logo, these two things. Okay, then it's showing an empty charging image on screen plus it's looping at that logo of what brand. So I am getting this, and phone is not charging, plus phone is not charging. Okay, I will remove this one. Phone is not charging. Those are my observations. These are my observations. My observations. Okay. Now, uh, now I'm using Gitra. I have decomiled the LK bin and trying to understand its function. From the observation, it is sure that in it the LK initializes UART display and other hardwares, not all maybe. So first thing we need to understand is how LK should be working. Understand LK. So for now my target is how the LK is loading and displaying image. This is my goal for now, and I'm actively working on it. So that's all the information I know till now. If I will know anything else, I will just add to this. I hope this journey completes very soon. It will be a very long journey, and hope you support. Thank you so much.